In this video, we will discuss the new enhancements in ETABS 21.2.0. Here are the new enhancements. For analysis, enhancements have been made to allow the number of internal threads for analysis, allowing the user to control the number of threads that can be used by the multi-threaded solver, as well as frame hinge assignment features have been enhanced with 4 new preset hinge assignments, and we'll go over each one of these. For output, users are allowed to disable the saving of individual fiber analysis results for fiber PMM hinges assigned to wall or frame objects. Also, analysis result data tables have been parallelized for increased speed during display or import. New feature in design, the AISC 36016 code has been added to steel connection design, and we'll go through each one of these. Also included, Eurocode 3-2005 steel frame design updates, concrete frame design for ACI 31819, as well as concrete frame design seismic beam column capacity using enhanced moments. And we'll also go through the features that have been included for Perform 3D. A lot of new export features allowing users added functionality in reference to piers and spandrels, as well as shell uniform loads. Let's take a look at where you can set the number of internal threads for analysis. So under the analysis menu, we'll take a look at advanced Sapphire options. And as you can see here, number of internal threads for analysis, you can set the maximum number of threads for a single analysis instance the process can use. So you can choose from the following. Program determined is the default and allows the analysis to use up to the number of physical cores simultaneous threads. The actual number of threads the analysis will use is displayed next to this option. So in this case, it's 4. So for user specified, this option enables you to explicitly specify the number of threads the analysis can use. Each additional thread used for analysis requires additional memory, hence must be taken into consideration when specifying this value. So this is typically recommended not to exceed the number of physical cores present in the system. Next, let's take a look at the frame hinge assignments. So under Assign, Frame, Hinges, you can see these new options have become available. So for nonlinear beam column, this option is intended to be used for most typical beam and column members, which are governed by flexural behavior and expected to yield at one or both ends of the member while maintaining elastic or nearly elastic behavior at the midspan. So you can see the image associated with that to see how this is assigned. And you can put your cursor over the eye to give you some more detailed information about that. Now for distributed plasticity, this option is intended to be used for frame objects that are expected to have complex yielding behavior over the entire length, for example, nonlinear buckling. Several integration types based upon common quadrature rules are available, which determine the integration points and weights used for the nonlinear hinges along the length of the frame. Next one is equal spacing. Similar to distributed plasticity option, this can be used for frame objects that are expected to have complex yielding behavior over the entire length. But this option adds evenly spaced hinges along the length of the frame object. This option can be used for all hinge types, and when used with a fiber hinge property, both elastic and nonlinear behavior of the frame in the hinge degrees of freedom is entirely governed by the hinges. Next, continuous spring supports. It's intended to use for piles or grade beams, which are supported by springs at specified intervals and are meshed at the intersection with these supports. This facilitates the placement of hinges between each support. So this option adds one hinge at the center of each frame element associated with the selected frame object, but if the frame object using the option is not meshed or divided into sub-elements, one hinge will be placed at the midspan of the frame. So you can see here, you can define your available hinges, and some other options are available to the user down here as well. Here's another new feature. If the Save Individual Fiber Response for Fiber Hinges option is not checked, the individual fiber results, for example, stress, strain, state, and status, will not be available after analysis has been completed. Next, let's take a look at some of the new design features that are included here in ETABS. If we go to Design, you'll notice Steel Connection Design is now available. So if we take a look at View Revised Preferences, here are all the new options. You'll notice for Steel Connection Design, AISC 316, we have beam-to-beam connections. And under this pull-down menu, you'll notice by default it's partial depth. We also have partial depth with top, full depth, as well as horizontal. And you have the ability to update any of these parameters. So for beam column connections, here you'll consider eccentricity in design when computing the strength of the bolt group. For beam column shear major axis, shear minor axis, as well as beam column moment major axis, as well as beam column moment minor axis here. Lastly, we have column footing, where you can enter in the plate thickness, anchor rod size, as well as many other different parameters here. Down here in the bottom right hand corner of the screen is the option to select the specific code you're interested in, as well as connection type, where you can select for beam-beam connection, toggling between auto, moment, and shear. Lastly, let's talk about some of the features that have been included for the exporting from ETABS to Perform 3D. To find these options, we'll go to File, Export. You'll notice you have the ability to export Perform 3D text file as well as a structural file. So some of the new enhancements include exporting nonlinear links from ETABS to Perform 3D, as well as exporting options has been expanded to include shell uniform loads in the global coordinate system. Export to Perform model functionality has been enhanced so that frame objects assigned a pier or spandrel label will be exported in separate element groups. So to access this, of course, we'll just click OK and it will generate a Perform 3D file, which can be opened directly in Perform 3D. Take a look at the website for importing and exporting from ETABS to Perform 3D. Here's kind of a comparative analysis of what the structure would look like in ETABS versus Perform 3D. So these are all the new enhancements that have been included in the latest ETABS 21.2.0. Please visit our website for more information. Thank you.